Hello and welcome. In the previous lesson, we learned the combination of the functions. In this lesson, we will learn the composition of the functions, with some examples. The function composition is a mathematical operation that involves combining two functions to create a new function. For example, if we have two functions, f of x and g of x, then the composition of these functions is denoted as f circle g of x, which is equal to f of g of x. This means that we apply g first, then apply f to the result of g. And the domain of this function is the set of all x in the domain of g, such that g of x is in the domain of f. And if we want to find g composite f of x, it will equal to g of f of x. And this means that we apply f first, then apply g to the result of f. And the domain of this function is the set of all x in the domain of f, such that f of x is in the domain of g. Example: if f of x equals x cubed, and g of x equals 3x, thus, f composite g of x is equal to f of g of x. Then, substitute g of x with 3x, so, you will get on f of 3x. Then, in the function f of x, substitute x with 3x, so, f of 3x will equal to 3x cubed, which is equal to 27x cubed. And g circle f of x is equal to g of f of x. And then, substitute f of x with x cubed, so, you will get on g of x cubed. Then, in the function g of x, substitute x with x cubed, so, g of x cubed will equal to 3x cubed. Another example: if f of x equals 1 over x, and g of x equals the square root of x, thus, f composite g of x is equal to f of g of x, which is equal to f of the square root of x. And f of the square root of x will equal to 1 over the square root of x. And to find the domain of this function, we need to consider two key points related to the square root and the division. The denominator cannot be 0, so the expression under the square root must be non-negative, so x must be greater than 0. Thus, we conclude that the domain of this function is the open interval 0 and infinity. And g circle f of x is equal to g of f of x, which is equal to g of 1 over x. And g of 1 over x will equal to the square root of 1 over x. And to find the domain of this function, we need to consider the conditions under which the expression is valid. The expression 1 over x inside the square root must be non-negative. And x cannot be 0, because the division by 0 is undefined. Therefore, x is greater than 0. Thus, the domain of this function is the open interval 0 and infinity. And if we want to find f circle f of x, it is equal to f of x, which is equal to f of 1 over x. And f of 1 over x will equal to x. Thus, the domain of this function is the open interval negative infinity and infinity. And g circle g of x is equal to g of x, which is equal to g of the square root of x. And g of the square root of x will equal to the square root of x. And to determine the domain of this function, since the square root is defined for non-negative numbers, thus, the value of the square root of x under the outer square root must be non-negative, so the expression x under the inner square root must also be non-negative. Therefore, x is greater than or equals 0. Thus, the domain of this function is the half open interval 0 and infinity. Exercise. If f of x equals 2x, and g of x equals x minus 1, then, prove the following relation. Pause the video and try to solve this exercise. The solution. To prove this relation, begin with the left-hand side of it. Then, in the numerator, substitute f of x and g of x, with their values. Thus, f of g of x is equal to f of x minus 1. And g of f of x is equal to g of 2x, and then, in the denominator, substitute f of x and g of x, with their values, so, f of x, will equal to f of 2x, and g of x, will equal to g of x minus 1, and then, f of x minus 1, is equal to 2 times x minus 1, and g of 2x, is equal to 2x minus 1, and f of 2x equals 4x, and g of x minus 1 equals x minus 2. Then, simplify the numerator and the denominator. Thus, the left-hand side, will equal to negative 1 over 5x minus 2. Now, our lesson of today is finished. See you later in the following lesson.